Hello everyone, a warm welcome to this channel. Today we will see on vector matrix and determinant worked examples. So we will see how to cover the contents of the vector matrix and determinant with an example. So let's start with the first example. Find the determinant of A, which is equal to 1, 3, 5, 0, minus 2, 0, 2, 4, 7. So it's just a matrix. A matrix is, as you have defined in your sessions. A matrix is an arrangement of objects in horizontal rows and vertical columns. So they are applied in different fields of study, such as in science and engineering, biology, physics, mathematics, computer science, engineering. They have different applications in different areas. So the determinant of a matrix is, let's recall that we have a 3 by 3 system of 3 by 3 as a matrix, which is order 3 matrix. The determinant of this 3 by 3 matrix is using the first row. We can use any row or any column to determine the determinant of the matrix. So let's use the first row, this one. So to find that one, A11 times its cofactor, where the cofactor of a matrix is minus 1 to the power of its position. It's 1 plus 1 times the minor is cancelling those elements which contain those rows and columns which contains a matrix, the element. So for instance, the minor of A11 is cancelling the row and the column, and the other part, the determinant of the other part will be the minor. So the determinant of A is using the first row. It is minus 1 to the power of 1 plus 1 A11 times or the determinant of this 2 by 2 matrix. And the determinant of a 2 by 2 matrix is obtained by this one minus this part. So we will obtain similar way for the other 2 by 2 matrices. So the determinant of the 2 by 2 matrices is this part, this one. So let's find the determinant for this one. So now let's tell you a good thing here. You can select a row or a column which has a lot of zeros to reduce your time, to use your time efficiently. You can choose a row or a column which has a lot of zeros if it has before doing the determinant. You can find the row or a column which is has a lot of matrices, a lot of zeros. So for instance, this column has 2 zeros, therefore we can determine the matrix using this column. For instance, if you cancel this one, the row, this one, and its cofactor, which is minus 2 times the cofactor is minus 1, the power of the position of 2 is 2 plus 2, the power of 2 plus 2 plus 2 times its determinant, which is 1, 5, 1, 5, 1, 5, and 2, 2, 7, 2, 7. So the determinant of this one is 1 times 7, which is 7, minus 5 times 2, which is 10, 7 times minus 10 is minus 3, times minus 2 is 6, so which is 6. Also using the second column, we got the value of the determinant is 6, but let's use the first row to determine the determinant. So 1 times its cofactor, which is minus 1, the power of 1 plus 1, and by cancelling those elements which contain those rows and columns which contains 1, so you cancel this one, so that 2047, 2 minus 2047, and the next one is 0 minus 1, the power of 2 plus 1, which is negative, and 0 times those cancelling those rows and columns on the which contains 0. So cancelling this one and this one, you get 1527. 3 5 3 cancelling this one and this one, we get 3, 5, and 4, 7. And the last one is the cofactor of 2 is 2 times minus 1 to the power of 1 plus 3, which is positive, and then cancelling those rows in columns of the matrix, and which contains 2, then 3, 5, and minus 2, 0, minus 2, 0. So calculating these determinants. So minus 2 and 7 minus 40, and this one is 0, and the other one, the whole is the 0, this part, because we multiply by 0, this part is 0, which is this part is 0. So the plus minus 1 to the power, which is positive, 2 times 3 times 0 is 0, minus of minus 10, minus 5 times minus is minus 10. So minus 40, and this part is 0, plus this one is minus 10 minus 20 positive times 2, which is 20. So minus 14 plus 20 is 6. Clearly, you can see that the determinants obtained using the second column and using the first row are the same. So we can use any row or any column to determine the determinant of the matrices. The next question is find the adjoint of the matrix A given that which is a 3 by 3 matrices, 3, 2, 1, 1, 5, 4, minus 2, 4, 6, 8. So to find the adjoint of a matrix, adjoint of the first, we compute the minor of each element, the minor of each element in the matrix. So the minor of any element is obtained by removing the column and the row that contains the elements. Therefore, for instance, the minor of 3 is 5 for the determinant of 5, 4, and 6, 8. The minor of M11, which is the first element, M11 is 5, 4, 6, 8, which is 14 minus 24, which is 16, The minor of 1 is by cancelling the column and the row which contains 1, so which is 2, 1, 6, 8, 2, 1, 6, 8, which is 16 minus 6 is 10. The minor of 4 is cancelling the column and the row which contains 4, which is 2, 1, 5, 4, 2, 1, 5, 4, 2 times 4 is 8 minus 5 is 3. So the minor of 2 is similarly, we obtained the minors of each of the elements in the matrices. Then M21 is this one, which is 24, M22 is 3, 1 minus 4, 8, which is 24 plus 4, which is 28, M31 is this one, so removing the column and the row which contains 1, which is 1, 5 minus 4, 6, 1, 5 minus 4, 6, which is 6 minus of minus 20, which is plus 20, which is 26, M32 is 26, M33 is 13. So the next one is if you compute the minor of each element in the matrices, then we compute the cofactor of the matrices. The cofactor of the matrix is the minor of the matrices times minus 1 to the power of I plus j, where I and j are the position of the element in the matrices. Therefore, C11 is minus 1 to the power of 1 plus 1 times M11, which is 16. And C12 is minus of the minor of M12, which is minus 10. C13 is the same with the minor of M13. C21 is negative of the minor of M21, which is minus 24. C22 is the same as M22. And C23 is negative of M23. C31 is the same as M31. C32 is the same by the negative, the minus of M32. And C33 is the same as M33. So this will give the cofactor matrix. Then the adjoint of the matrix is the transpose of the cofactor matrix. The transpose of any matrix is writing the rows into columns and columns into rows. So we can write C11, C12, C13 in column, C1 in column 4. So 16 minus 10, 3 is, we can write 16 minus 10, 3. Minus 24, 28, 11 in column. So writing in that form, we get the adjoint of the matrix. So the adjoint of the matrix is after computing the minor and cofactor and transposing the cofactor matrix, we get the adjoint of the matrix. The next question is find the inverse of a matrices. The inverse of a matrices is obtained in two ways. One, by applying an elementary operation, writing the matrices and an identity matrices in front with the same order with matrix A, then applying elementary operation, then transform by elementary operation. A will change to an identity matrices, and the identity matrix will be changed into an inverse of a matrix, which is using an elementary operation. The other one is using determinant and adjoint of matrices. So using determinant and adjoint of matrices, we can find the inverse of the matrices adjoint of A over the determinant of A. So every matrices, any matrices to be inverted, its determinant should be different from 0. So let's find the determinant of the matrices using the determinant definition. So using the first row, we can find the determinant. So 2 times the determinant by cancelling the rows and columns which contains 2. You get this one minus 3 times this one, then we get minus 5, which is different from 0. So the matrices, this matrices is an invertible matrices. Hence, we can find the inverse. So the first task is finding the adjoint of a matrix, as we have done in the previous example. We can to find the adjoint of a matrices. We are going to determine the cofactor matrices. The cofactor matrices. So cofactor of a matrix is obtained by minus 1 the power of its position times it is the minor of each element of the matrices. So the first one, C11 is 10, C12 is 50 minus 15, C13 is 5, C21 is minus 4, C22 is 4, C23 is minus 1, C31 is minus 9, C32 is 14, C33 is minus 6, as we have done in the previous this example. We can compute the cofactor matrix. Now, transposing this cofactor matrix, we get the adjoint matrix. So clearly, 10 minus 15, 5 is changed into the columns. The rows will be changed into columns. The rows will be changed into columns, or the columns we can change into rows. Therefore, the inverse of the matrices is the adjoint of the matrices over its determinant. So this is the inverse of the given matrices. This is the inverse of the given matrix. So the matrices times its inverse gives an identity matrix. Matrix times its inverse gives an identity matrix. So this is how to find the inverse of a matrix. The next question is how to solve the given system of linear equation. How to find the solution for a given system of linear equation. There are different methods to find the solution to the given system of linear equation. So the first one is matrix inverse method. The other one is Cramer's rule. The other one is Gauss elimination, Gauss-Jordan, and the others. So using the question is use matrix inversion method to find the inverse of this matrix. So using matrix inverse method, given the system X is equal to B, then multiplying both sides by its inverse, you get this one. Then A inverse times A gives 1, which is an identity. Then as a solution X is directly obtained by multiplying the coefficient matrix with the column and vector B. So we can use this one, which this method is said to be the inverse matrix method to determine the inverse, the solution of the given system of linear equation. So the writing in this form, Ax is equal to B, the coefficient matrix is this one, the column vector, which is the unknown vector, this X, Y, Z, the column vector be this one. So first is that the coefficient, if it is invertible, we can find its inverse. So therefore, the determinant of the matrix is -1, which is different from 0, so it has an inverse. Then A inverse is obtained by finding the adjoint of the matrices and the determinant of the matrices. Clearly, the adjoint, by using the other procedures, the adjoint is this one, and dividing by its determinant, you will get this one, A inverse is this one. Then we multiply this inverse matrix with a column and vector matrix B. Then we get a 3 by 3, 3 by 1 matrices. So X, Y, Z is equal to A inverse times 1, 6, 6. So multiply 1 times 1, 1 times 6, plus 1 times 6. And the next row is 1 times 6 minus 3 times 6 plus 2 times 6. And the last row is minus 1 times 1 plus 2 times 6 plus minus 1 times 6. So we get this one, so which is 13 minus 5, and 5 is the solution to the system of linear equation. So this is how to use inverse matrix method to find the solution to the system of linear equation. The other one, using Cramer's rule, how to find the solution of the system using Cramer's rule. So x plus 3, x plus 3y, x plus 3y plus 6z is equal to 2, 3x minus y plus 4z is equal to 9, and x minus 4y plus 2z is equal to 7. So the Cramer's rule applies the following. So it will going to determine the determinants in x, the determinant of y, the change in y, and the change in z. These determinants are obtained by replacing, for instance, by replacing the column vector, which is 297. If we are going to determine the value of x, we replace this column vector by the coefficients of the x, the first in the coefficient matrix in the first row. So this is a determinant obtained by replacing the first row, the first column by column vector 297, and this determinant is obtained, the change in y is obtained by replacing the second column by the column vector 297, and similarly this determinant change in z is obtained by changing the third column by the column vector 297. So then we can, if you divide the matrices, these determinants by the determinant of the coefficient matrix, we can directly obtain the solution. So the coefficient matrix to the system is 1, 3, 6, 3 minus 1, 4, and 1 minus 4, 2, and the column vector B is 297. Then the determinant of the matrices using the first row is minus 58. Then the change in x, which is a determinant obtained by replacing the first column of the coefficient matrix, the first column of the coefficient matrix by the column vector B, So it's replaced 297. Then the determinant will be minus 160, and the change in y is obtained by replacing the second column of the coefficient matrix by this column vector B, which is 297 here. You can see this one. We obtain this determinant 58, and the change in z is a determinant obtained by replacing the third column with the column vector B, so which is 29. Then the solution to the system x is obtained by the change in x, the determinant replaced by the x coefficient with over the determinant of a, which is minus 116 over minus 58 is 2, and y is the change in y over the determinant of the coefficient matrix, which is minus 58 over minus 58, which is minus 1, and z is minus 29 over the determinant of the coefficient matrix, which is minus 58, which is 0.5 or 1 over 2. So this is how to use Cramer's rule to find the solution for a given system of linear equation. The other concept under this matrix and determinant is the eigenvalue and corresponding eigenvector. Given a matrix A, we can find the eigenvalue and the corresponding eigenvector by using this one. So AX, which is equal to lambda x, then writing, moving this one to the other side, which becomes A minus lambda IX, which is equal to 0, where x is different from 0, and I is a matrix, an identity matrix, which has the same order with the matrix A. If a matrix is a 2 by 2, then I is a 2 by 2 identity matrix. If it is 3 by 3, then it becomes a 3 by 3 matrix. So substituting, it becomes this one. So that adding these two matrices by after multiplying by lambda, we get 3 minus lambda 2, 2, and 6 minus lambda times x. X is x1, x2, which is a eigenvector, which is equal to 0. So let's determine first the eigenvalues. Let's determine first the eigenvalues from the coefficient matrix. So 3 minus 1, that is obtained by using determinant. So 3 minus lambda, 2, 2, and 6 minus lambda, determinant. This determinant is obtained by 3 minus lambda times 6 minus lambda minus 4, 2 times 2, which is this one, and this one is said to be the characteristic polynomial or the characteristic equation to the given matrices. Then factorizing this one, what are the numbers where their product is 9 minus 9 and their sum is minus 40, which is minus 7 and minus 2. So lambda minus 2 times lambda minus 7, which is equal to, so the eigenvalues are lambda is equal to 2 and lambda is equal to 7. So let's find the corresponding eigenvectors. So 3 minus lambda, 2, 6 minus lambda, x1, x2, which is equal to 0, substituting the lambda value, 3 minus 2, 2, 2, 6 minus 2, x1, x2 is equal to 0, 1, 2, 2, 4. So x1, x2, then multiplying the matrix with the coefficient, this column vector, you get x1 plus 2x2 is equal to 0, and 2x2, x1 plus 4x2 is equal to 0. So clearly you can see that when we multiply the first equation by 2, you get the second equation, so that x1 is equal to minus 2x2, and x2 is different from 0. Therefore, x is x1, x2, which is x1 is clearly minus x2, and x2 here, then giving xt is equal to x2 is equal to t, so t times minus 2, 1 is the corresponding eigenvector for the eigenvalue lambda is equal to 2. And the eigenvector corresponding to lambda is equal to 7 is obtained similar way by adding the lambda, by subtracting lambda from the system, the given matrix, the product of the given matrix, 3 minus 7, 2, C2, and 6 minus 7, x1, x2, which is equal to 0. So subtracting that one, we get minus 4, 2, 2, and minus 1, x1, x2, multiplying the matrix with this column vector, you get minus 4, x1 plus 2x2, which is equal to 2, and 2x1 minus 2, which is equal to. So multiplying the second equation by minus 2, you get the first equation, so that both equations are the same. So implies that x2 is equal to 2x1, and x1 is different from 0. So the eigenvector is x is equal to x1, x2, which is equal to x1, and x2 is 2x1. So giving x1 is equal to t, so t1, 2 is the eigenvector corresponding to lambda is equal to 7. So this is how to find eigenvector and corresponding eigenvalues. Now let's come to the next chapter, which is vectors and scalars. A vector is a quantity which has magnitude and direction. For instance, acceleration, force, and others. And a scalar is a quantity which has only magnitude, temperature, area, something like that one. So a unit vector, finding the question is a unit vector in the direction of a vector given, in the direction of a plane vector given 1 over 2i plus radical 2j. So to find a unit vector is obtained by dividing the vector by its magnitude. Dividing the vector by its magnitude. The magnitude of a given vector is obtained by square root of the square of the components of the vector. So 1 over 2 the whole square plus the square root of 2 the whole square. So it gives 1 over 4 plus 2. So adding that one, we get 3 over 2, which is different from 1, which is not a unit vector. So to find a unit vector in the direction of this vector, then u, the unit vector, v, which is equal to u over the magnitude of u, which is 1 over 2i plus radical 2j over 3 over 2. So the unit vector is this one. The unit vector is 1 over 3i plus 2 square root of 2 over 3j is the unit vector. The other one is a dot product, the dot product of vectors. The dot product of any two vector is a scalar. The dot product of any two vector is a scalar, and the dot product of any two vectors u and v is obtained by the product of the components of its vector, its numbers, the components of its vector. So u dot v, the dot product of v and v, u1 times v1 plus u2 times v2 plus u3 times v3. So it's given that u is this one, v is this one, and w is this one. Now find the dot product and check that the vectors are orthogonal. Two vectors are said to be orthogonal if their dot product is 0. Then let's compute the dot products. U dot v is equal to 3 times 5, 3 times 5, 7 times minus 3, minus 2 times minus 3. So 15 minus 21 plus 6, which gives 0. So clearly 0, if it gives 0, u and v are orthogonal vectors. U dot w, u1 times w1 plus u2 times w2 plus u3 times w3. So 3 times 0, 7 times 1, minus 2 times minus 1, which gives 9, which means that u and v are not orthogonal vectors. W dot v, so w1 times v1 plus w2 times v2 plus w3 times v3. So it is 5 times 0 minus 3 times minus 1 and minus 3 times minus 1. So minus 3 plus 3 gives 0, and it shows that w and v are orthogonal vectors. So this is how to find the dot product of two vectors. The other one finds the angle between the vectors. Find the angle between the vectors u and v. So to find the angle between the vectors, we can use the definition of a dot product. The definition of a dot product says that if u and v are non-zero vectors, and if there is theta in the angle between u and v, then the dot product of u and v is obtained by the magnitude of u times the magnitude of v times the cosine of theta, the angle between them. So to find the angle between these two vectors, let's find first the magnitude of the two vectors. The magnitude of u is 2 squared plus minus 1 squared plus 2, which is 3, and the magnitude of v is the square root of 1 squared plus minus 1 squared plus 0, which is square root of 2. So, and the dot product of u and v is 3. Then to find the angle between theta, we can use this definition, and cos theta is equal to u dot v over the magnitude of u times the magnitude of v. So u dot v is 3 over the magnitude of u is 3, and the magnitude of v is radical 2, so which becomes cancelling 3 by 3, we get 1 over radical 3. So theta is equal to cos inverse of 1 over radical 3, which gives pi over 4, which is just 45 degrees. So this is how to find the angle between two vectors. So we can use dot product to find the angle between two vectors. The other one, let u and v be given. Let u and v be given. V is this one. V is this one. U is this one. They said u is this one and v is this one. 3i minus j minus 2k, and v is 2i minus 3j plus 1 over 2k. So to find the projection of u on v and to find the projection of v on u, they are different. So let's recall the projection formula definition. The projection of u on v is the dot product of u on v over the magnitude of v square times v. The magnitude of v square over times v. So first we need the dot product of the two vectors. So u dot v is 3 times 2 minus 1 times minus 3 and minus 2 times 1 over 2, which gives 8. And let's find the magnitude of u and v. So the magnitude of v the whole square is 3 square, which is v is this one, sorry, and u is this one. U is this one. So 3 square plus minus 1 square plus 2 square, which is 40, and the magnitude of u is 2 square plus minus 3 square plus 1 over 2 square, which is 53 over 4. So the projection of u on v is u dot v over the magnitude of u v square times v, which is 8 over 40 times the u vector. And the projection of v on u is u dot v over the magnitude of u the whole square times dot u, which is 8 over 53 over 4 times the u vector, which gives this one. So this is how to find the projection. So the projection of U on V is parallel to V, and the projection of V on U is parallel to U. So this is how to show the projections. The other one is cross product of two vectors. The cross product of two vectors is another vector, which is easily obtained by using the concept of a determinant. So we write first the ijk on the first row, then we write the second row will be written for the first vector, and the third row will be given to the second vector. So using the determinant concept, we can find the cross product of two vectors. So you have given U is 3i minus j plus 2k, and V is 2i plus 3j minus k. Then the cross product of U cross V is ijk. Then you write the U vector 3 minus 1, 2, and then the third row, it will be the second vector 2 minus 3 minus 1. So that using the determinant concept, we obtain the determinant, and the cross product of the two vectors is another vector minus 5i plus 7j plus 11k. So which is how to find the cross product. The second question is find a non-zero perpendicular vector to both vectors U and V. Now here I want to remind you that cross product can be written, can be asked in such either of the two. Either find the cross product of the two vectors or find the perpendicular vector to both vectors. So the cross product of any two vectors always gives a perpendicular vector to both vectors. The cross product of any two vectors, is a perpendicular vector to both vectors U and V. So the question is to ask the cross product of the two vectors. Finding a non-zero perpendicular vector means that find the cross product of U and V. So U cross V is, you will write on the first row ijk, and then the first vector U 2 minus 3, 1, and the second vector on the third row 1, 2, 4. Then find it by using the determinant concept, the perpendicular vector. The perpendicular vector is 10i plus 9j plus 7k. Let's check whether it is perpendicular or not. To check two vectors are said to be perpendicular if their dot product is what? 0. So U cross V is 2i minus j plus k times 10i plus 9j plus 7k. So it becomes that 20 2 times 10 is 20, minus 3 times 9 is minus 27, 1 times 7 is 7. So 20 plus 7 is 27, and here minus 7, which is clearly you can see that U is the cross product of U and V is perpendicular to U. And similarly, V dot U cross V is I plus 2j minus 4k, dot is 10i plus 9j plus 7k. So 10 2 times 9 is 18, minus 4 times 7 is minus 28. So 10 plus 18 is still minus positive 28, minus 28 is 0. So clearly the perpendicular, the cross product of two vectors is perpendicular to both vectors. Okay, thank you for watching this video. Please share, like, and comment the video lectures.